Today we're going to prove that 1 minus 1 over 2 squared times 1 minus 1 over 3 squared all the way to 1 minus 1 over n squared is equal to n plus 1 over 2n for all integers n greater than or equal to 2. Now this is a proof we're going to want to solve by mathematical induction. Now in order to start that process, we want to find the p of the lowest term. Now the lowest term for this specific sequence is 2 because we know n is greater than or equal to 2. So therefore we're going to find the p of 2, which is equal to 1 minus 1 over 2 squared. Which then simplified is 1 minus 1 over 1/4, which then equals 3/4. 3/4 is equal to the left-hand side. So we need to solve for both the left-hand side and the right-hand side. So now we know that 3/4 is equal to the right-hand side. So now we want to solve for the right-hand side. On the right-hand side we get n plus 1, and again we're going to substitute 2 in for n, so we get 2 plus 1 over 2 times 2, which is equal to 3/4. And because the left-hand side is equal to the right-hand side, therefore we know that the p of 2 is true. So now that we know that the simplest term is true, we can move on to prove that this whole sequence is true and equals this equation. Now in order to do that, we want to suppose that for all k greater than or equal to 2, and in this statement right here, we're pretty much you're just substituting k in for n. So we're going to suppose that k is greater than or equal to 2 for all k of 1 minus 1 over 2 squared times 1 minus 1 over 3 squared all the way to 1 minus 1 over k squared. And then we can call this sequence, we also have to substitute k in for our right-hand side, which gets us k plus 1 over 2k. And then we can call this sequence in this term, we're going to call this pk. So now we have our substitution. We want to show that 1 minus 1 over 2 squared times 1 minus 1 over 3 squared all the way to 1 minus 1 over k squared. So we have pk, and then we're going to add one more term to pk. So we're going to do pk plus 1. So we're going to add another term, which is then 1 minus 1 over k plus 1 squared. So we're just adding one more term to the sequence, and therefore we also have to do the same thing to the right-hand side and put k plus 1 in for k, which gets us k plus 1 plus 1 over 2 times k plus 1. Or that also can be written as k plus 2 over 2k plus 2. So now we have our substitution of what we want to show. We can continue on with our proof. And we know that because we have our pk, and we know that this is equal to pk, because 1 minus 1 over 2 squared times 1 minus 1 over 3 squared all the way to 1 minus 1 over k squared is equal to k plus 1 over 2k. Again, that's our pk right here. And you notice the similarities between this and this right here. So therefore, we can substitute this k plus 1 over 2k in for pk plus 1 here into this, our sequence right here. So therefore, when solving for our left-hand side, we get k plus 1 over 2k times 1 minus 1 over k plus 1 squared. And again, that's just because we know that these terms are similar, therefore we can just substitute these values right here into our pk plus 1 sequence. So now that can be simplified into, we're just going to distribute this into the parentheses. So we get k plus 1 over 2k times 1, which is k plus 1 over 2k, minus k plus 1 over 2k times k plus 1 squared. Now we're just going to want to continue to solve for this equation and continue to simplify. In order to simplify, we have to find like terms. Therefore, we're going to multiply k plus 1 squared into the bottom of this equation, so therefore we can subtract it to. And then we get k plus 1 times k plus 1 squared over 2k minus k plus 1 over 2k times k plus 1 squared. I'm going to bring you back over to this side. And again, we're just going to, excuse me. This is times k plus 1 squared. That's all over minus k plus 1. And sorry, the door closed over there, distracted me a little bit. So, but we're going to continue to simplify and solve. So now that we find that we have a like terms here, we have k plus 1, therefore we're going to pull that out, which gives us k plus 1 times, and we're actually just going to distribute this out as well. Like, actually, no, we'll save that for later. We'll make it look neater. K plus 1 squared minus 1 over 2k times k plus 1 squared. So now we know we can simplify because we have a common term, top and bottom term. So we know that this can be canceled and this can be canceled. And we're also going to distribute this out as well. So we're going to get k squared plus 2k plus 1 minus 1 over 2k times k plus 1. Which then can be simplified to k squared plus 2k over 2k squared plus 2k. Bring it back over to this side right here. Therefore, we know that we can take out a k from both terms, the bottom, top and bottom term, which gives us k plus 2, k times k plus 2, over k times 2k plus 2, which then we know equals k plus 2 over 2k plus 2. So that's our left-hand side. But you notice something, that our left-hand side is equal to our right-hand side. Therefore, we proved that this is true. So therefore, our left-hand side is equal to k plus 2 over 2k plus 2, which is also equal to our right-hand side. Therefore, by mathematical induction, which is the proof we just used, we know that 1 minus 1 over 2 squared times 1 minus 1 over 3 squared all the way to 1 minus 1 over n squared is true for all integers Therefore, by mathematical induction, we know that 1 minus 1 over 2 squared times 1 minus 1 over 3 squared, all the way to 1 minus 1 over n squared, equals, excuse me, I forgot to put that in there, equals n plus 1 over 2n, not k, 2n, for all integers n greater than or equal to 2 is true. So by mathematical induction, we know that 1 minus 1 over 2 squared times 1 minus 1 over 3 squared times 1 minus 1 over n squared equals n plus 1 over 2n for all integers n greater than or equal to 2. We know that that is true based on our mathematical induction proof. So again, just to review, by mathematical induction proof, you have to first find the p of the smallest term, which in our case is 2. So p2 on the left-hand side, we get 3/4. On the right-hand side, we also get 3/4. Therefore, we know that p of 2 is true. Now we want to find our substitution, which is that we know that for all k greater than or equal to 2, and again, we're substituting k in for n, all k greater than or equal to 2, the sequence 1 minus 1 over 2 squared times 1 minus 1 over 3 squared all the way to 1 minus 1 over k squared is equal to k plus 1 over 2k, and that's what we call pk. Now we want to show that the same sequence plus another term, which is our k plus 1, so 1 minus 1 over k squared times 1 minus 1 over k plus 1 squared is equal to k plus 1 plus 1 time, or divided by 2 times k plus 1, which is also k plus 1 over 2k plus 2. And then we concluded that, then we continue on, and we knew that because pk is found in this equation, that we can substitute k plus 1 over 2k in for that sequence of pk plus 1 and pk plus 1. And therefore, we just continue to simplify and solve, and eventually we found that the left-hand side is equal to the right-hand side for pk plus 1. And therefore, by our mathematical induction process, we know that our beginning statement is true. My name is Dalton Tremaine, and I appreciate you for listening. Thank you very much.